Here we are handling a old IIT question. The problem is like this from two-dimensional motion. The position vector of a particle is given as r equal to a cos omega t and a sin omega t. Then how is the velocity of the particle? Is it directed towards the origin, away from the origin, parallel to position vector or perpendicular to position vector? Let us first find out what is the velocity itself. Therefore, we can think of that, right? So position is given as a cos omega t I cap plus a sin omega t j cap. We can find velocity as rate of change of position or displacement. Differentiate that once with respect to time. Then a is a constant. Differentiation of cos omega t is minus sin omega t. You are differentiating with respect to time, for which omega is a factor. So I shall multiply the result with omega, which is called like chain rule. I cap plus a is again constant. Differentiation of sin omega t is plus cos omega t. Again I have to multiply with omega chain. So velocity vector is minus a omega sin omega t I cap plus a omega cos omega t j cap. I got both position vector as well as the velocity vector. How it is it directed towards velocity vector is directed towards the origin? No, that's not definitely the case. Directed away from the origin. We cannot say those things because directed towards the origin means its x and y components has to come towards the origin, right? But here, this is plus I going away from the origin. This is plus j going away from the origin, right? This is minus I, of course. From the positive side, you can say it's approaching the origin, but this is plus j, it's again going away from the origin. Therefore, their combination is neither going to be towards or away from the origin. And then we have, so these two options are definitely ruled out. Is it parallel to position vector or perpendicular to position vector? It is definitely not parallel because the ratio of their components, that means this ratio, x components ratio and y components ratio is not equal to 1. So obviously they are perpendicular, right? But I want to prove that they are perpendicular. How can I prove that? It's very easy to prove that. Let us find out the direction of this vector, say tan theta 1, which is nothing but the slope of the vector. When the vector is having both x and y components, yeah, like this, slope of the vector means y component by x component. So tan theta, slope of the first vector is a sin omega t, y component by x component, by a cos omega t. A and a can be cancelled. So this is tan omega t. That's the slope of the first one. Let's find the slope of the second one, this one, slope of velocity. Y component is a omega cos omega t, by x component is minus a omega sin omega t. A omega will cancel. Then cos omega t by sin omega t is 1 by tan omega t. It's reverse. It's reverse to this. Therefore, these slope are reciprocal to each other. As slopes are reciprocal, we can say they are perpendicular to each other. If the slopes are reciprocal, they are going to be perpendicular to each other. Or there is altogether another way to solve that. What is another way is, if two vectors are perpendicular, their dot product has to be equal to 0. Then find the dot product of both of them. Dot product of r dot v is, you shall multiply their x components, y components and add all of them. X component of the first one is a cos omega t. The x component of the second one is minus a omega sin omega t plus y component of the first one is a sin omega t and the y component of the second one is a omega t, a omega cos omega t. Look at these things, right? A and a square minus sin omega t cos omega t. This is plus sin omega t and cos omega t. So both of them cancels and the dot product is 0. As the dot product is 0, we can say the two vectors are perpendicular, right? So you can solve either the first way or alternatively this way too. Both of them comes to the same answer that these two vectors are perpendicular to each other. That means these two position vector and velocity vector perpendicular to each other. That's how we can solve the problem. That's it. Thank you for watching.